Our next type of reaction in our series of chemical reactions is called a single replacement reaction. So far we've done two reactions. The first one was a synthesis, where you were actually making things or synthesizing things. The second reaction was a decomposition. Okay, now those are actually harder than this one. A single replacement reaction actually is not a real difficult reaction. So I have the number 3 up here because this is our third type of reaction. So our single replacement reaction, in this reaction, a single element will replace another element from a compound. Okay, that is a single replacement reaction. Now, you'll see the word here, I put single displacement, because that's a new term that's come up in the last number of years, and I've always learned it as single replacement, so that's what I'll use. Okay, so a single replacement reaction. Now, this compound that we're talking about here is an aqueous compound, which simply means that that compound is dissolved in water. Okay, so if I have a generic equation for this, and we're going for this reaction and the next one, we have some generic equations. You have a single element A, and that A is placed into a solution of compound BX. So BX is something that's dissolved in water. Okay, and what happens is this element A actually comes over and kicks out element B. So what happens is you see element B forms a new solid all by itself, and then A goes ahead and combines itself with what B was combined with. Okay, and that's why this is called a single replacement reaction, because B is going to get kicked out and A comes in and replaces it. Okay, so it's kind of like dance partners on a dance floor where some guy comes in and kicks out another guy trying to get the girl. Well, this is the same thing. Okay, now typically metals will only replace other metals or hydrogens. So in other words, something that's going to form a positive ion will replace a positive ion. So an element that forms positive ions replaces positive ions. Okay, so that's what happens in this. All right, now just to show an actual example of this, okay, I have copper, and that's solid copper over here, okay, and that's going to react with an aqueous solution of AgNO3. Okay, now an aqueous solution of AgNO3 would be a beaker like this one, okay, that's full of silver ions, and that's what I have here, and nitrate ions, because those two were something that were soluble and would break apart. And we're going to talk about solubility actually in our next VodCast. Okay? So here's what happens. Okay? As you look at this, okay, this copper actually comes over here and it's going to kick out this silver. And that's what you see has happened over here already. Okay, this copper came and kicked out that silver, and so that copper could combine with that nitrate, and now this silver is all alone. Okay, so the products of this reaction are silver that's now a solid plus copper, which has now combined itself with that nitrate. And that's a single replacement reaction. Now, I'm going to show you this as a little short video. So what I have here is a solution of silver nitrate, and I'm going to take this copper metal and I'm going to put that into the silver nitrate. Okay, so again, up here, this copper is a solid piece of copper. If I put that, ooh, that's not what I wanted. Okay, this copper is a solid piece of copper, and so that's going to react with that silver nitrate. So as I put this in here, okay, just this is more of an FYI thing, the water molecules and the nitrate ions in the aqueous solution are not shown in order to simplify this process, okay? So here's what happens. These silver ions that are free go in and attach themselves to the copper metal, and the copper metal actually goes into the solution. So if I go step by step here, okay, one of the things that you'll notice is here comes the silver. The silver is coming in, okay, and the electrons are being transferred, and the copper ions are being released, okay? And so that's kind of what's happening in this particular reaction. It's a single replacement reaction. Okay? So, let's look at some other single replacement reactions. Okay? Predicting these is actually pretty simple. Okay? The hardest part, again, is always writing the formulas. Okay? And you have to be able to write formulas. So here is a reaction of magnesium and zinc nitrate. Okay? And this magnesium is going to come in and it's going to kick out that zinc. Okay? So that zinc becomes the solid. All right? Now, this magnesium here then is going to bond with the nitrate. And you have to predict what charge magnesium will be. And we've done this enough that you know magnesium is a +2 charge. So I'm going to write magnesium nitrate. Okay? So that would be the reaction that's going on. And again, we can see this on the atomic level. Okay, if I go back to this website here, okay, where over here, I'm going to take this magnesium and I'm going to put it into this solution of zinc nitrate. And if we watch this, okay, here come the zinc ions. They're going to attach themselves. And these big zinc ions over here have now become a metal. And the magnesium actually goes into the solution and forms with the nitrate, okay? So that's what's going on in this particular reaction. So, let's just do a couple of these. Aluminum plus lead nitrate, okay? The aluminum is solid, and that's one thing I should have put on here is that these are aqueous. Okay, this aluminum goes in and kicks out the lead. So I'm going to get lead that's going to be a solid. And then the aluminum is going to combine with this nitrate, but you need to remember that aluminum forms a +3 charge, nitrate's a -1 charge. So this is going to be 8th NO3, 3. And this is aqueous. Okay. That is actually left dissolved into the solution. Okay, let's do another one. Iron plus silver acetate. See if you can predict the products. The iron kicks out the silver, so the silver becomes the solid, and then the iron attaches itself to the acetate ion, and you can kind of choose whatever ion you want here. Iron can be a +2 or a +3, so you can choose whatever you want. And I guess that's one thing I should have said is I'm not balancing these, but you should definitely go back and balance. Okay, and so zinc plus H2SO4. Okay, and this is where I said that the metal is going to kick out any other metal or a hydrogen. Well, in this case, the hydrogen is positive, so it's going to get kicked out. But when it gets kicked out, it actually has to form H2, which in this case is a gas. It has to form hydrogen. It cannot just form H, because hydrogen is one of our diatomics. And then plus Zn, oops, I guess I wouldn't need parentheses, sorry. ZnSO4, which is aqueous. Okay, so that's the single replacement reaction. Okay, now, there are single replacement reactions with acids. Okay, here's another one. that we can do, and go ahead and write the products of this reaction. And what you should be writing is MgCl2 plus H2. Okay? Or you may have wrote it as H2 plus MgCl2. Doesn't matter. Either way is correct. Okay? Now, write the products of this reaction. Now, what I'm guessing you wrote is AuCl plus H2. But what really happens is no reaction. Okay? And one of the things that happens is just because you can write a reaction does not mean the reaction will work. And I actually want to show you this. So when you get done watching this, okay, and you come to class, ask me to show you the demo, and in class, as soon as I have time, I will show you this, and we can see what's happening and go from there. But just because you can write a reaction does not mean the reaction will work. So how do we know whether or not a reaction will work? Well, we have to use what's called an activity series. In your packet of information, find the activity series. Okay, what the activity series is, it's a list of elements that arranges elements from most reactive to least reactive. And this is the key right here to using the activity series. An element will only replace those below it on the activity series. Okay, and I'm going to go to the next page because this will be a little bit larger. Okay, so this should be your activity series that you should be finding. And what this activity series basically shows is the list of most reactive elements to least reactive. So basically up here, these elements are the most reactive. And the elements down here are the least reactive. Okay? And then down here, this activity of halogens, okay, this is a whole separate list that we'll talk about a little bit later, okay? Now, just so you know, okay, what I told you earlier is also on this sheet. An element will replace from a compound in aqueous solution any of those elements below it. So this is also just another reminder, and that is on your activity series sheet. So basically what this is saying is lithium will replace anything on this list, and gold down here replaces nothing on this particular list. Okay? And again, this is always not a complete list, but it's a list that's good enough for us to use right now. Okay? And if you look at some of these elements, you see lithium, rubidium, potassium, sodium. Okay, and those are group 1 elements, which we know are the most reactive metals in the periodic table. Barium, strontium, and calcium are group 2 elements, which are the second most. Okay, so it should make sense that some of those are in the top of the element, the bracket list. Okay? So what we're going to look at is we're going to look at a reaction between barium and cadmium sulfate. Oops, let me write that better. Okay, so that's a yield sign. So I'm going to look at barium, and I'm going to look at calcium, and I'm going to find them on this list. Okay, and when I find barium on this list, barium is right here, and calcium is right here. Okay, so because barium is above calcium, barium will replace it. Okay? In our activity series right here, barium is above calcium, so it will replace it. So what I will get is calcium plus BaSO4 as my products. Okay? So that particular reaction worked. Okay, let's look at another reaction. Okay, let's look at copper reacting with magnesium sulfate. Magnesium carbonate, excuse me. Okay, so I want to see if this reaction will work. So what I do is I go to my list, okay, and I find copper. Copper is way down here. And I find magnesium. Magnesium is up here, okay? So now, because this magnesium, okay, which is in this compound, is higher than copper, which is way down there, okay, magnesium being higher than copper, this is a no reaction. So we write NR. NR stands for no reaction. Okay, we cannot write the products of it because the reaction doesn't work, because this copper cannot replace anything that's above it. You can only replace things that are below it. Okay? Let's look at one more. Let's look at a reaction of silver plus hydrobromic acid. Okay? So we got to find these two on the list. And one of the things you'll notice is that hydrogen, okay, even though it's a single H here, it's listed as H2 on this list. Okay? And then silver is way down here. So will this reaction work? And the answer is this would also be a no reaction. Okay, because silver is below hydrogen and silver would need to be above hydrogen to make this reaction work. Okay? So that's our activity series. Now, okay, the activity series for metals is all up here. Right here is a separate activity series for halogens. And this activity series works the same way, except it only works for halogens replacing other halogens. So fluorine will replace everything, but iodine replaces nothing in these two. Now, okay, the way this looks then, okay, when you start actually putting a reaction here, we'll do a reaction that just deals with halogens. First of all, you'll notice the equation is a little bit different. If I have F2 plus KBr. Okay, there's my reaction. Now, one of the things to note is you don't have a metal. So this F2 right here is not going to kick out the K because this is a negative ion. So negative ions will actually only kick out other negative ions. So this F2 could only kick out that Br. And because F2 can kick out anything, this reaction will work, and this will become FBr plus K. No, it won't. What am I thinking? It will not become that. The F is going to kick out the Br, so it's going to become Kf plus Br. Okay? And that Br is diatomic, so that has to be Br2. Okay? Let's do another one here once. Okay? Let's try, I need to look here. Cl2 plus NaI. Okay, Cl2 plus NaI. So if I look on my list here, okay, Cl is above I, so this reaction will work. So what will happen is the Cl is going to go over and kick out the I. So this is going to become NaCl, and then the I forms its diatomic I2. Okay? So sorry about my little goof there with this particular equation, but this is what happens. Okay, you should now be able to go ahead and work on the single replacement worksheet.